Okay. Can you hear me?
All right, we're about to start our first presentation.
Okay, so before I start, Arno is setting up a meetup in San Francisco on November 4. For any of you who can make it. If you're interested in going, go to the QR code and there'll be a form and you can fill it out to tell him that you're going. And I'll leave this up after the presentation if you want to go there. All right, so that's me on the left, and my brother on the right. And I was around 11, I think, when I remember this clearly. I was sitting on my bed, and my best friend walks into the room, and he's like, "There's this new game. It's really good. You got to go see it. There's this maze, and you're in it, and you're going around, and there are dots, and there's a guy chasing you, and it's really good." And I get all excited, and I run to the TRS-80, and I program my first Pac-Man. And I had never seen it, right? So I programmed many after that, but that was the only one I ever wrote without ever seeing the original game. And a couple years ago, I wondered, like, how bad was it, really? Like, how bad could a Pac-Man be when it's written by, like, an 11-year-old based on a verbal description from his friend who had seen it for 5 minutes once at Highs. So I'm like, okay, I want to find out how bad it is. So I had all my old tapes, and some of them were documented like this, right? Like I had written on my dad's typewriter, Space Shuttle on top. Like, in my defense, I'm ESL, so it's okay. And actually, so it turns out that I didn't write this down, but at the end of this is my original Pac-Man. So I tracked down the tape, computer tape B, and I'd written a TRS-80 emulator a couple years before in Go. So I tried it. I got the WAV file, and I got it, and it wouldn't read. And I looked at the audio, and some of the audio, like when you look at the audio and you try to, like, it won't read or whatever, you look at the audio signal and it looks like this. So for example, this is actually from Ira. He gave me a WAV file a couple of months ago, and this is high-speed audio, and so this is maybe decodable, but right here, forget it. Here's another example of, like, audio that's super not salvageable. You're losing dozens of bits or whatever. But sometimes the audio, the human could look at it. Like, this is low speed, and there's some kind of 120 hertz signal overlaid on top. And emulators have a hard time with this because the things are everywhere. I mean, the zero crossings are all over the place. But a human can look at it. So I thought, okay, well, why don't I write a program to sort of, like, help decode this? This is another example. It's a bit hard to see because the signal's in blue. But this part here, the peak to peak is really high. And then here, the peak to peak is really low. So if you calibrate on the low one, then you end up triggering on this one. I don't know if you can see this one little spike over here. This is like little noise spike over here, little noise spike over here. So you need to, like, adjust over time where you think your peaks are going to be. So there's a lot of work you can do, but if a human can look at it and figure out where the spikes are, then maybe a computer can too. So I wrote a program to sort of read these, figure out where the pulses are, and write a clean version so that I could import it into an emulator. And I wrote it first in Java. And so this was a command line tool. You give it the WAV file, and it spits out a clean WAV file. And then what happened is that every time it failed to do the right thing, I was like, well, how did it fail? And I would bring it into Audacity and go to the right sample and inspect it. I said, this is a terrible way to sort of, like, write this tool. What I really need is a tool with a user interface. So I rewrote it all in as a web app. And it's available here. And so if any of you have a WAV file that you want cleaned up, you can go here and drop your file into it. Yeah, so this is my-trs-80.com/cassette. And I have a couple sample cassettes here if you just want to play around, if you don't have a WAV file and you just want to play around with the web app. But otherwise, you drop so this is the B, the famous B tape. And this is a WAV file of both sides of the tape, so it takes a little while for it to analyze it all. It does quite a lot of work. For every program that it finds, it uses multiple different decoders to try to figure out which one works best and which one has the fewest decoding errors. It tries high speed, low speed, 250 baud. It tries if it's inverted. Sometimes there was the two, the left and the right were inverted, so the whole signal is inverted. But what you get at the end is something like this, with 3 panes. You have here on the left, you have the cassette directory. On the top here you have the sort of metadata, and on the bottom here you have the actual waveform. So if you're curious, you can just go in here and zoom in. And this is low speed. Low speed is, you've got a clock pulse here every 2 milliseconds. And then after that, you're either missing a pulse for 0 bit, or you've got a pulse for 1 bit. So this is very clean, actually. This is quite good. But sometimes it gets messed up, and you can look at it, and you can see, like, OK, what went wrong? And if you find something like this, if you find like you've got a WAV file, which is clear to you what the pulses look like, but my program doesn't decode it, send it to me, and I'll just modify my program to do a better job of it. And that's kind of how it got better, is like Ira kept on sending me WAV files, and I kept on improving it. So totally do that. And so it's pretty fun to go through and sort of learn about the system. If you zoom out, after a while, instead of showing you the bits, it actually shows you the bytes. This is what over here, we. So you can sort of go through and look at all the different programs on the file. You can export the whole program here as a CAS file. That is, the whole tape will be exported as a single CAS file, or a WAV file, which is the cleaned up version, where I generate very clean signals. But the interesting thing is so the way that I wrote cassette files at the time, like that directory, that typewritten directory, is every 50 counts of the counter, I would write a new program, right? Like at 100, 150, 200. And each one of them I would write 2 or 3 times, just in case something got damaged. So this is how this thing decodes it. On the left, there's a track, which is like which one, like 0, 50, 100. And then there's several copies of each. So here detected a copy 1, and here detected a copy 2 on the left. Now in this case, copy 2 is dimmed, and that's because the binary is identical. So for archiving, this is useful because when you're archiving a tape, there might have multiple copies, and it's good to know you don't have to archive the second tape. It's identical to the first one. But if they're different, then maybe you want to archive both because you don't know which one is actually correct. And so for each one, you can go over here, and it'll show you the binary for it up here, metadata up here, like where it starts, where it ends. You can export it, just that one, as a CAS file or WAV file. In this case, it's a basic program, so it detected this. So you can export it just as a BAS file directly, like this is a tokenized binary. And you can add notes and names and stuff like that, and it'll remember all that for you. The reconstructed WAV file looks like this. It looks a lot cleaner, so it's kind of boring looking. But it basically looks like this. And this imports pretty well into just about every emulator. Or you can make a real cassette if you want to bring it onto a real physical machine. So I did all this, and I was exporting WAV files back into the emulator and so on. And I thought, well, OK, but I kind of want to see the bytes right here. Like, I don't want to just see pulses. So I added a way to see the binary. And then now you can sort of go through and see. So this is like D3, D3, D3. That's the start of a basic program. And S53 is the single letter name that you gave it when you do csave, and so on. So you can see all this stuff. This is a Space Shuttle program from the first program on this tape. So then I saw this. So I'm like, well, OK, but it's basic and it's tokenized. That's kind of hard to see. Why don't I detokenize it? So over here, you could go to basic program, and you can see the program itself. So this is really useful when you are dealing with problems. So when there's a decoding problem, over here, it'll look pretty good for a while, and then it'll just turn to garbage. Like at some point in the program, it'll just turn to total garbage. What you can do here is you can go and you can click on like the first token that's garbage, and it'll jump in the waveform to that part of the audio. And that's so you can see like, okay, this is actually where things go south in the audio, and you can see, okay, this is the pulse that actually got misunderstood or something like that. And then so it goes both ways. You can select in the audio, it'll jump to the basic program and vice versa, or also in the binary. It's kind of hard to see, but this BD right here is highlighted. So you can highlight, for example, a whole section over here and go to the basic program, and that'll be highlighted here, and the audio will be highlighted. So it's pretty good to jump back and forth if you want to try to find out what actually happened in the decoding. And so I was looking at this basic program, I'm like, well, I want to run it, and I don't want to like export it, right? So then I wrote an emulator. So what you can do here, on the tab here, there's 3 different emulators. One is, and its cassette is the original audio. So if I do this, I do cload, this is the famous Space Shuttle. I didn't author this. I think I got this from some magazine somewhere. So this is getting the original audio. But sometimes that won't read because maybe the original audio is messed up, but the cleaned up audio works well. So then you go to the emulator for the reconstructed. So this is now a totally different emulator that's fed a different cassette, that's mounted a different cassette. And you can do that. The emulator runs in real speed, so it's slowed down to be the correct speed, unless the cassette motor is on, in which case it goes full speed, because presumably you don't need like the authentic 40-second wait time or something. And then auto run is a special thing where if I recognize the program, like in this case it's a basic program, you can skip all the cassette altogether. It'll just boot the emulator straight, and it just writes the program straight to memory and runs it. So if you just do this, you get the program right away. So that kind of saves you a step if you don't care about the cassette part.
Lawrence, will it play out the computer speaker so you can load it into a real TRS-80?
Oh, will it play the WAV file?
Yeah.
No. Oh, so Tim's question was, will it play the WAV file out of the computer speakers of your Mac? No, so it doesn't do that. It's interesting. So, and then you could plug that right into a TRS-80.
So if you get it, you're like, I want to put it in my Model 1.
No, never occurred to me. That's actually awesome. Yeah. Also, if you have questions, it's easier for me if you ask right away. That's just go ahead and talk.
Is this set up for a particular version of BASIC?
The question was, is it set up for a particular version of BASIC? That's a really good question. By default, it's at Model 3 because that's what I grew up on. But over here, if you hover over the emulator, there's a gear here, and you can set it to a different model, a different level of BASIC. Like for example, you can reboot into a Model 1, or you can even a level 1 if you need to do that. Or different amounts of RAM or whatever. And there's also here, you can change the phosphor and all sorts of fun stuff.
I was wondering on the decode. So if I were to feed a Pocket Computer 2 program into this.
Okay, so there's only support Model 1, 3, and 4. Yeah, there's no Pocket Computer. Yeah.
I have a quick question. You said you can save it in CAS or WAV. Can you use that then to load up a CAS and convert it to WAV and vice versa, like save it?
Yeah, so the question was, can you save it as a CAS or WAV and convert it back and forth? Is that the question? Yeah, so you can do a CAS file, which most emulators just take, or a WAV file that you can do. And then I'll show you later how you can go from CAS to WAV also just directly. But here you can just save as either one directly. And it'll copy the speed that you read it at. So if you read it at 500, it'll save it at 500 or 1500. And there's a way, you can also change that, but I'll show you later how you can change the speed if you want to do that. And then there's a screenshot. And then so if you want to associate something, like in this case, there's no screenshot for this program. So let's say, let's run it. And this whole idea was like, okay, I was going to have a lot of these tapes, and I was going to like read all of them and find out information about them. So you take the screenshot, and now it shows up here, so that when you're like going through the programs, you can remind yourself, okay, this was that program or whatever, and that's all saved for you. So let's go down here to the second to last program, and this is the famous BASIC that I wrote. I don't know what this is. Okay, you ready? This is the BASIC that I wrote based on my friend's description. this is you right here, the rectangle, and you can sort of go around and you can take the things. This is even more awful than I would have predicted. Right, there's like one ghost and it's a star, and you're a rectangle and you're just free to move in this very large maze. There's no inertia, right? You have to click every time. There's a countdown of time. I don't know why. There's like, your score goes up every time you move. Yeah, this is like, yeah.
I think it's pretty awesome.
Okay, it got better after that. Okay, so mission accomplished. I got this program back, but now, what do I do? I've got like zillions of tapes. So I've got all these tapes, and all of these have my programs, and they all have like 10 or 20 programs on them. So I'm thinking, like, how's this going to work now? I'm going to, for each one, every time I want to play a program, I have to like find the tape it's on, and then import its WAV file, and then scroll through this thing, and then play it, or whatever. It seemed wrong, and then I started thinking about all the floppies that I have. These are all floppies from the time, and all the programs I have that I wrote at the time. And this one says like DOS +2 on it, I think. This is not at all what I want, right? Like, I don't want a tool that has to do with like cassette decoding to be where I go to actually run the programs. That should just be a tool that just decodes cassettes. What I really want is sort of like, I want to invert that. I want the computer to be the center of my focus, and I want a library of all my tools that I can easily play on that one computer as if I had a physical computer. So I wrote my-TRS-80.com, and it's available to everybody if you just want to play it. But if you go there, it inverts everything. So now we're back to the same emulator, but now the emulator is the focus of the website. So now you start with the emulator, and of course you can just go on and you can program it. So if you just go to that thing right now, you can just start programming on a TRS-80 if you just want to like play around with it. And you can do different, just like the other one, you could do different phosphors or different models if you just want to play around with it. But the key part of this is now that you have your own software library that you can load onto it. And by default, if you're not signed in, there's this little folder icon in the upper right. And it brings up the retro store. The retro store is something that Arno and Sasha made a couple years ago. And they have stickers for it in the back if you want to get one of those. And the idea, I think this was for the Android app, is that right? So they made an Android app where you could run TRS-80 stuff, but like you just launched just like this, and there's nothing to do, it's kind of boring. So they made a service, a web service, where you can go on and get a list of what they figured were copyright legit programs. So you can get all these programs and play them. And then I think it's also available from Tris.io, is that right? Okay, so the same API is used here, so you can go and you get all these programs. Like, for example, here's Breakdown, Pete's Breakdown, and you just click play, and it loads it straight into the thing. This happens to be a disk version of it, and it just runs it. And then so all of these programs are just runnable straight from here. Maybe Zaxxon. That's what just runs. So at the very least, you can just go on, you can do a little bit of basic programming, and you can play some old games and load some old floppies and stuff like that, and be up and running pretty quickly, without having to like install a program and all these things. But the real magic is when you sign in. You sign in with your Google account. So this signed me in automatically because I had done it before. But once you sign in with your Google account, then when you bring up the library tab, you now have two tabs. The retro store is still there if you want to do that. But then you have your files. And your files is simply all the files that you've uploaded. By default, there's nothing in here. And there's a program down here, import file. So here's where you can import like a CAS file that was saved from the cassette tool, or BAS file, command file, anything you want to. Not a WAV file, because you would just decode that on the cassette tool, but any other kind of file format, like a floppy file, disk, JV1, JV3, and you can just upload it, and it'll store it for you. And then you can just have your library. And then so this is like all the stuff that I've uploaded. So for example, at the top here is Apartment Paths, which was on the G tape. So this is just a program that I wrote, again, when I was like 12 or something like that. And then so you import it here. This was uploaded as a BAS file. And then you can just play it directly. This is a top view of my apartment when I grew up. And the lower left here is my bedroom. And you can type like bath, and it'll show you how to get to the bathroom. I don't know what inspired this. I have no idea. And there's a little pencil icon, and here you can enter all sorts of information about it. So this is how you can like sort of work through your library and keep track of things. Give it a name, the file name, any kind of notes you want, the release year, and so on. There's a tagging system here, and you can add all sorts of tags yourself. Some of them are automatically generated, like back here. For example, the type, like this is BAS. So it automatically assigns a BAS tag. If you're missing a screenshot, it'll assign that, or missing note. You can add your own tags. Like, for example, I have a tag called mine, just to tag all the programs that are mine, or my tapes, the ones that came from my tapes. There's one called Retro Store if you get it from the Retro Store. And then you can just run it here. And while you're running, you can hit the screenshot icon here, this camera, and then it'll record screenshots for you. You can record as many screenshots as you want to. So this is a good way to remember what does the program look like, just to trigger your memory. I've got lots of Pac-Mans, and they all look kind of different, so it's good to have a screenshot for that. There's a shared button here, and by default it's off, because it's your program and you don't necessarily want other people to get to it. But once you turn it on, and you run the program, the URL that's in the URL up here, whoa. You can then copy and paste it to, let's say, to anybody else. So this is an incognito window. And anybody can just run the program directly. So this is a good way to sort of share your programs. And if you find a command file, either yours or anybody else's, and you just want to give it to somebody real quick, you hit the share button, and you paste the URL, and you give it to somebody. And within like a few seconds, they can be playing your program. You can also analyze the program. So this is a hex dump, and this is an annotated hex dump. So this is pretty nice if you're not sure what these program formats look like. What does a command program look like? What does a disk program look like? So this is like the first 8 lines here are actually the same 16 bytes, but there are different parts of it are highlighted. So here it highlights the first 3 bytes, D3, 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 which tells you that it's a header, like a basic program. And then the next one is the name, and then it shows you for each byte over here, what is it doing? This is the line number 10, and then this is the content of the line is CLS, the end of line marker, and so on, and the pointer to the next line. So you can sort of walk through these file formats and try to understand what's going on. And here the basic is the decoded basic. And for all the different types of programs, like this is a 3BN. 3BN is an extension that I think George made up, and it stands for Model 3 Binary. But it's the format that is stored. When you type system on a tape to run a binary program, that's that format if you take it out of the CAS file. So over here, you can get the hex dump, and it explains to you like how it's done and what is this is the name event, for example, and so on. And so it explains to you how it's broken down. This is also useful if it doesn't read correctly and something's broken. It'll go through and it might tell you, for example, there's a bad checksum, or maybe it just goes off the rails here, and this is kind of a useful way to see like why didn't it read correctly. And information about all the different packets in there. It'll disassemble binary programs so you can flip through it, figure out what's going on. And frequently what I found is that I would import the same program multiple times, maybe from different tapes or for different floppies, so it automatically detects the duplicates and tells you what they are. In this case, I'd already put 2 of them in the trash, so that's fine. But if you find more than one of them, then you can go see them and compare them and decide like which ones you're going to trash and keep only one of them. You can do, so here's like, and when you have enough of them, it gets hard to find, so you can just type a search. So for example, if I type Pac, then I get all my Pac-Mans, or Scarf-Man here also. But here's the Son of Pac-Man in the lower right, and all the other ones here. And this is where the screenshots are pretty useful. Oh, and if you search for something and it's not found, then the daemon is disappointed in you. Yeah. It says, try doing literally anything else. You can and floppies, of course, work. And for floppies, when you go to edit it, it'll tell you what's on the floppy, and you can see all the things, and you can run them directly from here, like you can run memtest directly from the floppy without having to mount the floppy. It'll just extract the file and just throw it straight into memory. Or you can import it, and then you can import one by one. A couple of days ago on the Discord, I think somebody said, I've got a floppy image on disk. How do I get a file out of it? And I think somebody said, well, just run in an emulator, and then there's a tool in the emulator to get stuff out. That's one option. Or here you just like upload the floppy file, and then you can just click the import button, and it'll just import it into your library, and then it'll show up over here, and then you can export it from here or do whatever you want, or just run it directly. So it's kind of a nice way to, and I definitely encourage you to like go on here, get an account, and just upload stuff, and let me know if anything would be useful. So then I had, I think I talked about some of these tools on Trash Talk, and people started using it to manipulate cassettes, and people said, well, this is great, but I don't really want to use a web tool. I really want just a command line tool to do some of this stuff. And I had already written this whole suite of tools. So all the various libraries and tools I had written. I wrote all these in, so these are all web tools, right? So they're written in JavaScript. They're actually written in a variant of JavaScript called TypeScript. Not many people know TypeScript, so real quick, JavaScript looks like C a lot. But it has no types. It's dynamically typed. So it's not easy to find out your errors at compile time. Like here, I've got a function called twice that doubles a number, but I pass it a string. And it's not until it runs that it would crash, which for a large system is really bad. In TypeScript, you add the fact that there's a number, and then it tells you Tandy is no good. You can't pass in Tandy. So if any of you are writing JavaScript, I definitely recommend trying TypeScript, especially for the larger programs. But I had written this whole suite of tools in TypeScript. A bunch of libraries, emulators, assemblers, disassemblers. The TRS-80 base is the one that knows all about the different file formats, floppies, and how to read them, command programs. It knows about half a dozen or a dozen different type of file formats and how to read them and write them and convert them back and forth. And so I ended up writing this TRS-80 tool here on the bottom, which is a command line tool. It's documented online, and I distribute binaries directly, and so you can just go to this site and download binary for Linux, Mac, and Windows, and so you don't have to like deal with anything. You just get this one binary and you can use it. And it's got a bunch of different subtools, so it's sort of a Swiss Army knife. It's like one of those tools that like you run the tool, and then there's a sub command that you give it to do different things. And so I'm going to go through these real quick because they're kind of interesting. Is that big enough? Is that good? So if you just run it, you get help on all the different things. And if you want to run help, for example, on a particular program, it'll tell you all the specific parameters for that one program. So just one of the nice things you can do, here I've got a directory of several different kinds of files. 3BN is that system file that you get off of a tape. A CAS file is a binary file that has all the proper headers and stuff like that, just like as if it were on a real cassette. Command files, disk files, and two different kinds of disk files, raw basic files, a WAV file. And what you can do is you can ask it, like, if you've got a bunch of these, you can say like what kind of file is this? And it'll tell you. And it's not just looking at the file extension, it's actually looking at the contents to see what it is. Like in this case, it told you that the name is Saucer because the name is built into the file. There's a bunch of different kinds of disk formats, like ways to store floppies as a file. There's JV1, JV3, and some of them are just called DSK. Some of them just get the extension DSK, but you don't know what a DSK file is. It could be any of the different file formats. So here it'll tell you, it'll read and say that's a JV3 file, and with 10 files. And it's pretty useful when you have a bunch of them, just to give it a wildcard, and it'll go through and tell you all of them. And that's kind of a nice way to just see, like, okay, what do I have? What are these files? It'll go through and tell you how many files are on there, and whatever information you can get. There's also a verbose flag that for some file types will give you more information. For the floppies, it'll tell you the sector length, the track range. Some of these files have metadata, like the floppy name or the date it was written and so on. It'll tell you all that. If you want more information about floppies, there's a sectors command. And the sectors command will show you like a sector map and all the various flags that you get for them. Like the track 17 here is marked as deleted, but what that really means is it's the track that holds all the directory information. That was a single density. This is a double density, so a lot more sectors. There's a verbose, no, it's contents. Flag, and that'll actually show you each sector. So this is pretty good if you've got a floppy and you just want to go through and see like what's on sector 17 or whatever. You can just go through and it'll show you the binary. This is a pretty easy way to just like walk through a sector floppy file. Hex dump is pretty great if you're trying to figure out, like before, you're trying to figure out like what's in a file in a way that's annotated. So for example, if I do the son of Pac-Man, this gives you, just like the website, an annotated version. So the hex line is duplicated, and it shows you here these two lines are the end of address, and then this two thing is the line number, the line 5000, and it actually decodes the basic to show you what is on that line. So it's pretty good just to like, it's useful for, you can use it for floppies, for example. It'll show you all the track information at the top, but this is exactly what's written in the file. And again, if you're not sure what these file formats look like, how they're encoded, or what's wrong with one of your files, do a hex dump and it'll try to help you out as much as it can. Like any information it knows about the file, it'll show you here. It's not just a regular dumb hex dump. Here's a CAS file. And so you can see all the zeros, and that's actually written into the cassette. There's a bunch of zeros at the top of a low-speed header, and the low-speed sync byte is over here, and 55 tells you it's a system program. These things are the scarf M, and so on. So you can figure out what's in these files. And for some of these things, like floppies, it can be hard to know what's in it. So there's a dir command. So for example, for this thing, it'll show you what's in the disk file. If you just want to know, it'll work for floppies. It'll work for, this is a simple CAS file. It'll work for WAV files. So you can give it a WAV file, and it'll quickly read it and then decode it and tell you what's in it. Okay, so the next command is run. This is one of those commands that I added because I could and not because I should. So basically, you run it, and it gives you an emulator right in your shell. I don't know how useful this is. I've found it kind of useful just to try things out quickly. So you can just be in BASIC. You can also give it, let's say, I'll do the son of Pac-Man. You can give it programs, and it'll just run it directly. It uses for the graphics characters, it uses the Braille, because the Braille commands are also 2x3. This is, I think, George's idea. You can run like Scarfman or whatever. You can run almost anything. You can run a command program, a CAS file. You can give it like a floppy, and it'll just mount it and run it. I found this to be surprisingly useful. You can also mount something. So you can, for example, mount, let's use Scarfman cast file. And then it's just mounting it. And then you can do, and then you can just like read it like normal. So this is useful if you have a cassette that has a bunch of data files on it. You might want to not just automatically run it. You want to just sit there and then you can analyze it, or you can read the data yourself or something like that. And you have Model 1, you can do Model 1 Level 1. There's an experimental thing called X-ray, and this is also from Sasha and Arno. And if you do this, then all it does is it runs a web server, and then you can go to it. And this is it's sort of experimental. I think Peter Phillips tried to put this into TRS-80 GP. I'm not sure that's ever released. But the idea is like it's a common way to sort of inspect a running computer. And it could be a physical computer. I think we tried it with Model 1 maybe, like with a TRS-IO, I'm not sure. Like just try to get as much information as possible out of the running machine. You can do stuff. Here, it might be hard to see on the display, but whenever any memory location is accessed at all, it highlights. So you can see on the top, I don't know if, now it's kind of hard to see, but there's some green dots all over the place in the ROM as the ROM is being read. There's a live disassembly down here. You can stop and single step through code and set breakpoints and memory locations. So it's still sort of experimental, but the idea is that you can debug maybe your own program or system or whatever this way if you wanted to do that. Okay, so the meat of the program is convert. Convert will try pretty hard to convert from any file format to any file format. And it can do, let's say, it can do Scarfman command. Command is the floppy version of an executable. But it can, for example, do a 3BN, which is the cassette version of an executable. And it'll just convert back and forth. And so you can do that. You can write it to a cassette file. You can write it to a WAV file, and it'll just take these like programs in. So it'll first convert from a disk to a floppy format, and it'll convert that to an audio file that you can then send out. It'll go in all sorts of different directions. The only thing that it really doesn't do, it doesn't write floppies, but I think it does everything else. You can also, for example, if you have a basic program, if you look at a basic program, it looks like this because it's all tokenized. But you can convert if you say ASCII, then you'll get the ASCII version. So this is good if you've got a basic program, you just want to see what it looks like. If you give it several files, let's say you give it like saucer and Scarfman, and you write out like a CAS file, for example, it'll put multiple files into a CAS file. In fact, in this case, it had to convert the disk one into a floppy format first, or you can just do a WAV file too. So this is a nice way to make a multi-program thing, and you can specify the disk speed. You can say 1500 or 500 baud or whatever. It also works the other way, where if you have a directory that's empty and you type, you can give it like a CAS file, and it'll write all of the files to the directory. So it'll go both ways. It'll archive and unarchive things. It'll unarchive WAV files too. And so this is the thing that people really wanted. If you have a WAV file and you just want to get all the files off of it, this is how to do it on the command line. You were asking earlier, like somebody was asking earlier, how do you convert from WAV files to CAS files? And that's how you do that. You could just convert from a WAV file directly to a CAS file, and all of the programs will be extracted and put into it. So go archive to archive, or archive to files, or files to archive. You can also do floppies. So let's say, so it wrote out all the floppies contents, and then you can run it. Let's say you run like a memtest, right? And then you can just run the memtest. So again, that's another answer to the question from the Discord a couple of days ago of like, how do I get a file out of a floppy? You can run this and just say convert the floppy name to a directory, and like all the files will be extracted. In fact, you can do, this is kind of dumb, I don't know why you would, but you can do a floppy to a CAS file. Oops. And it'll take the floppy, convert all the command files to cassette versions, and then write the CAS file. I don't know why you would do this, but if you wanted to, it'll do that. So it's sort of a Swiss Army knife kind of convert program that you can do all sorts of things with. And since I had it, I had an assembler. So you can also assemble programs. Like you could say, where is it? So I wrote a game called Wolf, and then so you convert Wolf to command, and it'll just write it out. And again, you can write to anything, to CAS or whatever. And this is a Castle Wolfenstein like 3D kind of game. You can also disassemble this. This has been useful for Ira because he's been doing a lot of disassembly of sys files and things like that. And it's pretty clever. This is like, so it assigns labels and it looks for code that's runnable. But for example, it tries to be clever about what is code and what is data. Like in this case, there's label 42, and then there's a bunch of code, and then there's a return, and then there's a bunch of bytes, and then there's another label that was jumped to somewhere else. Well, no code jumps to that code in between, so it's probably not code. And so in this case, sure enough, this is where the player's position and orientation and other data is stored. And so it detected that and just wrote bytes instead of trying to decode all those things as no ops. And if it's, and if you've got ASCII in here, it'll decode it. So it's a pretty clever disassembler. And I've noticed, I like the hex that looks like this, 0x8000, but that's not very legit. That's a C style. But if you prefer this format, you can get a $, some assemblers like that, and you can do, I think H is the more legit. Is that right? I think that's the more legit historical one. So you can do any of those. Okay, the last command is one again that I'm not sure. I did it again because I just want to experiment with stuff. It's REPL. REPL is a computer science term. It's an acronym. It stands for read, evaluate, print, and loop. So it reads a line from you of code. It evaluates the code. It prints the results, and then it just loops. And this is useful if you're trying to learn Z80 assembler. So you just type a Z80 command like no-op. It'll assemble it. Like I'll show you, assembled 00 is the opcode for no-op. It'll tell you whatever information it has about no-op, which in this case is not very interesting. It'll execute it. And it'll tell you what happened in the computer. So it read that byte from 00, and then it'll show you all of the different registers and which ones, it'll highlight the ones that change, like in this case, the PC I bumped to 1. So I can say, for example, load HL1234, and here it assembled to this. Here's what the load command does. It read the 3 opcodes, and then HL changed over here, and PC changed over here. I can say push HL. And so, for example, when it runs, it read the push, but then it pushed 1, 2, and 3, 4 to this memory. And the stack pointer changed. And then you can inspect memory, and it'll show you all of RAM, which in this case is not very much. This is the code we wrote, and this is the stack at the very top of RAM. So if you're trying to experiment with Z80 and try to see like what happens with these different commands, it's kind of very interactive way to see what each command is doing. So that's the TRS-80 tool. And I keep adding stuff all the time, especially in response to people asking me for stuff. So feel free to use it and ask me for things, and I'll just happily add stuff. The code that I wrote has a lot of different tools that are kind of unused, so it's kind of nice to put them all into this one tool so you can all use it. Any questions about the tool? The last thing I want to show is, I showed this last year. there's an IDE. And this is helpful for writing programs. And so I added a few things there. Like last year when I did the demo, it was barely usable. It was still like a demo version of it. But now it's way more friendly. If you actually open a file from your local file system and you edit it, you can do save and it'll save it right back to that one file. So it acts like a local IDE. You can export as a command in CAS and WAV file. And ended up using the IDE to just real quick for those who weren't here last year, it's a assembly language editor for the TRS-80. So here's the program on the left, here's a simulator running on the right, and as you change the program, like I can change the program in real time, and it'll reassemble it and run it on the emulator in real time. And so as a test of this to see like, can I actually do something useful with it, I wrote this Wolfenstein thing that I was talking about earlier. It's a bit hard to see on this squish display, but it's basically a 3D game. I think Tim, you started writing something like this, a Raycaster, a couple of years ago. Yeah. So it's a couple thousand lines. So it was pretty useful for me to actually write something substantial with it and see like, is it actually like a good tool, and it helped me. So if any of you are writing games or anything like that in assembly, I encourage you to at least try it. The assembler is pretty compatible with ZMac and all sorts of other assemblers. And the turnaround is really fast. It was really great to, like as I'm typing code, to see the display change and whatever I needed to do. Okay, I think that's it. Is there any questions about any of those tools?
Got a question?
Yep.
So when you log in with your Google account, does that store the files onto your Google Drive space?
No, I wish it did. There was no way for me to do that, so I store it on my drive. So I store it under your account name, but under my storage area. So these files aren't very big, so I'm not using up a lot of space. But yeah, it's in a database that's in my name on the Google servers. And you can download the whole thing. There's an export all button. So if ever you put a lot of stuff into it and you get insecure that maybe one day the website will go down, there's an export all, and it'll like give you the archive of everything you've ever uploaded. Yeah.
Do you support hard disk format?
No, I don't support any hard disk formats. No. Yeah, Keith?
Lawrence, this is an amazing body of work here.
Yeah.
Like, I was impressed like 3 minutes in, and then I was more impressed 6 minutes in, and 15 minutes and so forth, as I would imagine everybody else is. In terms of the number of hours, the effort here is huge. How many hours have you spent on this, and where the hell do you find the time?
Yeah, I don't know where I find the time to do this. It's just fun. This is like, it's all fun. Yeah, so far. Yeah, I don't know.
I saw before you have your folder and you can share it. Is there a way of creating a share where it's publicly visible, where you say if somebody wants to come check it out, or can you submit it to be part of the regular library if they deem it's interesting enough?
Yeah, so the question is like when you share a program from my TRS-80, right now you just share the link, so you have to know this magical link, but is there a way to sort of like publish all the links maybe that you've shared or have some kind of public library? There isn't anything like that right now. I would like that, especially if nobody uses it right now, so there's not a lot of motivation for me to make that, but I think if more people used it, I would find more way to have like, okay, this is like your list of shared programs, or maybe some common thing of like, this is all the things that anybody has shared anywhere like that, and then it'd be kind of fun. I think a lot of us have programs we might just want to do that with. Yeah.
Is there any sound support in the emulators like when you're writing games?
Yeah. Yeah. The question was any sound support. What's a good program to show that with?
Dancing game? Yeah.
I don't think I have the daemon on here. I'll do ghosts. So when you run it, there's a speaker icon right here, and if you unmute it, oh, you can't hear it up there. No, you're asking me if there's any sound, but so.
I've got it on.
Oh, you got it on? Okay.
Barely. You might need to turn it up.
No, that's okay. Yeah, there's no. Yeah. Anyway, so yeah, you have to opt into it, but there's the simulator, the support sound, yeah. And also, like, if I don't know if you'll hear this, but when you boot it, it's the yeah. It's got all the track sounds and everything. Anything
Is
else?
that really difficult to implement in TypeScript?
You mean the sound?
Yes.
So the question was sound difficult to implement? It's not the TypeScript that was hard in this case. There are two ways to do sound on web. One of them is the old way that's going to go away, but you can just play sounds out of nowhere. And the new way is much more sophisticated and harder to run, but you need the user to opt into it, which is why it defaults to false. I can only turn it on as a result of a user click. And that's to stop websites from just harassing you with sound as soon as you go there. But it was pretty tricky to sort of like, it's not meant for exactly this where I'm generating sounds on the fly. It's really meant for more like you're playing a sound from a movie or something like that. So the floppies are recorded sounds, and everything else is actually take the cassette output and I just generate it and send it out on the fly. Anything else? We're good? Okay, so yeah, I just want to say again, like our node is doing this thing on November 4th. So sign up here if you're in San Francisco area. It should be fun. Okay, thank you.